Welcome everyone to this talk entitled Mathematics at Oxford. My name is Richard Earl. I'm Director of Undergraduate Studies in the Mathematics Department. It means I chair the teaching committee there, and roughly speaking I'm in charge of the undergraduate degrees. And I'm also a tutor at one of the Oxford colleges. We've been in the Andrew Wiles building now for 5 or 6 years. It's a lovely spacious building that you'll see plenty of undergraduates around on a weekday. Especially down here in the mezzanine, one floor down, you've got this large teaching area, and that space on the right you see there will not only be full of desks with undergraduates working at them, or if they're not there, they may be in one of the many lecture theatres, the largest of which is there on the left, that's L1. It's got capacity 350, and in the normal run of things we'd all be in there today at an open day. So Oxford had some success in the last REF, the Research Excellence Framework, going back a little bit now to 2014. And you might think as an undergraduate, how will the research that's done in a department affect you? You won't actually be doing research yourself. But if you look at the top 4 departments there, a few things are noteworthy. First of all, clearly because of the GPA, they're doing top-level research. But the numbers are very big for the number of submissions that were made as well, meaning they're large departments. And where that's important for undergraduates is when it comes to your 3rd and your 4th year, it doesn't just mean that you're being taught by the experts, but also the sheer size of the department means that there'll be a range of options that you can take. Having a large department means there'll just be that much more algebra, that much more analysis, that much more physics, that much more fluid dynamics that you get to choose from. So here you have on this table a list of the mathematics degrees that we offer within Oxford. You can see there's 1 main mathematics degree and 3 joint degrees there, all of which you can do in a 3 or a 4-year variety. So you can graduate with a bachelor's, BA, after 3 years, or if you do well enough in the 2nd and 3rd year, which means getting a 2-1 in the 2nd and 3rd year, then you can carry on to the 4th year if you wish, and about 2/3 of our students choose to do that. It's worth saying that whilst the joint degrees can't contain as much mathematics as the main maths degree, this is all mathematics of the same level of difficulty. So the BA Maths and Philosophy, or the M.Math.Phil that you see there, that will contain largely the pure mathematics from within the mathematics degree, and the other half of the degree being filled with philosophy and logic. That's not to say that mathematics is any less difficult than it is in the mathematics degrees. It's identical in that sense. And each of those degrees have a core first year. So core in the sense that there are no options. So here we've got a list of things that would be available to people doing mathematics or mathematics and statistics, and the other joint degrees would have other core years, so there'd be more computer science or philosophy listed there. Now some of these words are really quite familiar, like integration, perhaps dynamics, probability, but they all come with a very different flavour at university. There will be, on the pure side, a much more of a sense of trying to do things rigorously, carefully, from definitions and axioms. The integration course that you see there isn't about finding out more integrals. It's about actually, what does it mean to be integrable? What functions can we integrate? What areas and regions can we assign? What regions can we assign areas and volumes? On the applied side, you'll see a much greater variety of mathematical models, whether they be deterministic or probabilistic, and you'll need all sorts of new techniques of mathematics to actually solve them. So these will introduce in particular things like partial differential equations. If you think about actually most functions in the real world, they aren't of the variety f of x. They're not functions of a single variable. They're functions perhaps of x, y, z and t, perhaps 3 spatial and 1 temporal coordinates, say like in the temperature in the room about you. And so you can then actually take derivatives in different directions, and what you're then doing are making partial derivatives. So there's all sorts of things you will meet there in, as I say, a core first year, but options kick in immediately into the 2nd year. And they they are involve the sort of flavours you would expect there. So algebra is listed there, or geometry and so on. There are all the sort of things you would expect are in a mathematics degree. But there are plenty of other things in the degree that you might not have expected. So you might have expected things like relativity and quantum theory there. It's not unusual for you to have seen mathematics applied to physics, but increasingly it's applied to the life sciences. Mathematical genetics is a huge research area in the statistics department. There are all sorts of other types of applied mathematics or other themes there. You can do a course that's about understanding the mathematical theory of information and how quickly that can be communicated, or how you might communicate it and be able to error correct and error detect at the other side. So there's all sorts of applied mathematics there that you might wish to do, as well as the things that you would expect on a degree. So you can't apply to Oxford to do a mathematics and physics degree. There is a great deal of physics that's optional and available within the mathematics degree, and you can actually finish with a mathematical physics degree. The way this has been arranged is that if you do, say, the first 3 years of the mathematics degree or the first 3 years of the physics degree, then you can then apply to switch into a specialised 4th year and finish with a mathematical and physics degree. So this MMath Phys is available to people who have done 3 years of mathematics or 3 years of physics at Oxford and then come and do this specialised degree. And that makes sense, because it doesn't really matter too much if you want to end up in theoretical physics whether you do a maths degree first or a physics degree. So this is how we've resolved this particular issue. So we've just got a few remaining slides now on how we teach at Oxford. In the photo you can see there is actually a room in Queen's College. The person at the board is my former tutor Peter Neumann, and what's going on there is a tutorial. So a tutorial is a small group teaching arrangement. There'll usually be one tutor in the room and perhaps 2, possibly 3 students there, and they usually last about an hour long. So this is obviously a very flexible individual way of teaching mathematics. The process, in a sense, starts with the lecture. So students meet mathematics for a first time in a lecture theatre. They will have usually 10 lectures a week, be about 50 minutes or so long. Perhaps you have 5 lecturers giving 2 lectures each during a week. Now, during these lectures, various things will be explained to you. Hopefully much of it will make sense, but there won't be that much chance to ask questions, and it will be the case you'll go away perhaps thinking you understood 60 or 70% of that, but there'll be plenty you still need to go away and think about. In many ways, this is the point of higher education, that this guided study helps you break down these problems for yourself in many ways, but you've still got tuition as a safety net there for the things you don't actually quite understand at the end of the week. So you're going to have about 10 hours of lectures, you're going to have about 25 hours, 28 hours of self-study, and then the end of the process pretty much is with that tutorial. So you've got a tutorial now, perhaps going through 2 sheets from 2 of those 5 lecturers, and you're discussing the various things you've had issues with, and it might be the 3 students in the room all have problems with the same particular exercises, or it might be they all found it quite easy that week, and it might be that Peter Neumann's telling them some extra beyond syllabus material, or it might be that the sheet was found quite hard, in which case it might be a back to basics approach, really trying to get the fundamentals understood that week. It can be a highly individual way of teaching. It's a nice way to teach for the tutors because they get to know their students that much better. I think it's nice for the students that they're able to build a rapport with their tutor and feel comfortable asking questions about things they don't understand. So this is how teaching is done in the colleges for the first year or 2. And then in the 3rd and 4th year, as mathematics becomes more and more varied, then the intercollegiate class system kicks in, and it will be the case that you go along with other students from other colleges and get taught by a specialist in those areas. There might be 8 or so students in those classes, and like I say, they'll be from various various different colleges. The point being that no single college will have teaching enough to teach the very many options that are available in the third and fourth year. So perhaps one final thing to say about tutorials, that they're very nice ways to teach when everyone engages in them appropriately. So you can imagine for those 3 students there's nowhere really to hide if they haven't worked that week. A student who wants to find out how how the problems that they couldn't do are resolved, wants to have their questions answered, has come along with a list of questions, will make much of that tutorial. And it might be the case that Peter's there not really answering questions with immediate answers, but asking further questions. What theorems do the students think are relevant? What problems have they met like this before? What do these words mean in the particular question? What's their rigorous meaning? It's much more the onus on the tutor to show the students how they could have done more for themselves, and then the next time round they'll be able to sort of like go that bit further with a problem than they've been able to do today. But that really means the students have to be engaged with their studies to make the most of this system. And finally, it's just about saying that we really are a university that still assesses largely by examinations. So at the end of the year, not the end of terms, at the end of the year there will be examinations. For later years, more of this can be project work of one kind or another, relating to, say, data analysis perhaps, or writing computer programs. But it's still going to be the case that the large amount of this is going to be assessed by exams. Anyway, I hope you found this talk useful. I'm signing off there.